we understand clearly, let's do an activity for relative density. Okay, so density, let's do an activity for density in your home easily. Density is a amount of mass, is a substance per unit volume of matter. Every substance have different density. To understand this idea of density, let's do an activity in your home easily. Okay, so first step, pour 1/4 cup of honey in a transparent glass. Okay, second step, pour 1/4 cup of colored water on top of the honey. Third step, pour 1/4 cup of coconut oil on top of the colored water. Okay, so the last one is honey, the middle one is colored water, the upper one is oil. Okay, so pour separately. Now notice how the different liquid from the different layers. Okay, why is it so? Different substance have different density. Okay, so which means for the same volume, a different substance, it have different, it it acts differently based on their weight differently. Okay, so heavier substance settle at the bottom like honey and float. The lighter material like oil, okay, tend to float. Okay, tend to float on the top. So we will understand every substance have different density. Okay, so next we'll move to the relative density. Okay, so we can compare the densities of two substances by finding their masses. Okay, so now only we saw. So thus relative density of a substance is defined as a ratio of density of a substance to density of water at 4 degrees Celsius. Okay, so we can compare the density of two substances by finding their masses easily. But generally, the density of a substance is compared with the density of water at 4 degrees Celsius because density of water at the temperature is 1 gram per centimeter cube. Okay, so mathematically relative density is expressed as density of a substance by density of water at 4 degrees Celsius. Okay, so that is the definition of relative density. So next we will move to the floating and sinking. Okay, so whether an object will sink or float in a liquid is determined by the density of the object compared to the density of the liquid. So it will, the density of a substance is less than the density of the liquid, it will float. For example, a piece of wood or balloon which is less dense than water will float on it. Any substance having more density than water, for example a stone, will sink on it, into it. Okay, you know very well about that. So next, the hydrometer is based on the principle of flotations. For example, the weight of the liquid displaced by the immersed portion of the hydrometer is equal to the weight of the hydrometer. So okay, so next we will move to the applications of principles of flotation. So one of the important application is hydrometer. So this hydrometer is based on the principle of flotation. For example, the weight of the liquid displaced by the immersed portion of the hydrometer is equal to the weight of the hydrometer. Okay, so hydrometer is based on the principle of flotation. Hydrometer consists of a cylindrical stem. Okay, it consists of a cylindrical stem having a spherical bulb at its lower end and a narrow tube. Okay, narrow tube at its upper end. So narrow tube is the upper end and then spherical bulb is the lower end. The lower spherical bulb is partially filled with lead shots or mercury. This helps hydrometer to float or stand vertically in liquids. The narrow tube has markings so that relative density of a liquid can be read directly. Okay, so the liquid to be tested is poured into the glass jar. The hydrometer is gently lowered into the liquid until it floats freely. The reading against the level of liquid touching the tube gives the relative density of the liquid. Okay, so hydrometer may be calibrated for different uses such as lactometers for measuring the density of milk. Okay, so next we'll move to, let's see the construction and working of lactometer. One form of hydrometer is a lactometer, an instrument used to check the purity of milk, whether the milk is purely mixed or not. Okay, the lactometer works on the principle of gravity of milk. The lactometer consists of a long graduated test tube with a cylindrical bulb with the graduation ranging from 15 at the top to 45 at the bottom. Okay, the test tube is filled with air. This air chamber causes the instrument to float. The spherical bulb is filled with mercury to cause the lactometer to sink up to the proper level and float in an upright position in the milk. Lower the lactometer floats in the milk. The average reading of the normal milk is 32. Lactometers are used at milk processing units and dairies. Okay, so the lactometer is an instrument used to check the purity of milk. Okay, so next we will move to the beyond C. We already saw that your body experiences an upward force due to the fluid surrounding when it is partially or fully immersed into it. We also know that pressure is more at the bottom and less at the top of the liquid. This pressure difference causes a force on the object and pushes it upward. This force is called as beyond force, and the phenomenon is called as a buoyancy. Okay, so the upward force experienced by a body when partially or fully immersed in a fluid is called upthrust or buoyancy. The object will float in that particular liquid. Okay, that force is called as a buoyancy. So what is the reason? The pressure differences, okay, causes a force on the object and pushes it upwards. That is known as a buoyancy. Okay, beyond force, or this phenomenon is called as a buoyancy. Okay, so most buoyant objects are those with a relatively high volume and low density. If the object weighs less than the amount of water it has displaced, the density is less, buoyant force will be more and it will float. The subject is known as positively buoyant. Okay, but if the object weighs more than the amount of water it has displaced, the density is more, the buoyant force is less, and the object will sink. The subject is known as negatively buoyant. Okay, so the buoyant force more, object will float, then it will be called as a positively buoyant. Okay, so that it will be float means it is known as a positively buoyant. Beyond force less, the object will sink. Okay, that is known as a negatively buoyant. So the object will sink means it is called as a negatively buoyant. The object will float means it is a positively buoyant. Okay, so can you differ? So in this floating object, we will say what? Because the sink object is sinking, then the buoyant force is less. Okay, that is positive buoyant. The floating, the buoyant force is high. Okay, that is a negative buoyant. You know that. So let's see the activity. In a first glass there is a salt water. Salt water provides more buoyant force than fresh water. Okay, salt water provides more buoyant force than fresh water. First we take two glass. One glass is poured with the salt water and one glass is float with the fresh water. Okay, so salt water provides more buoyant force than fresh water. So then only the in the ship will float in the salt water. Okay, so because buoyant forces depends as much on the density of the fluids as on the volume displaced. Okay, so let's do an activity. So in the first class there is a salt water, so that egg is floating. In the second glass there is a fresh water, the egg is sinking. Why? Because salt water is denser than fresh water because of salt content present in it. Okay, so the egg will sink in fresh water because of greater density than the salt water. Okay, so the egg will float salt water because salt is added to water, density becomes greater than that of egg. So that makes the egg floats while it is sinking. Okay, so next we move on to the Cartesian diver. The Cartesian diver is an experiment that demonstrates the principle of buoyancy. It is a pen cap with a clay. The Cartesian diver contains just enough liquid that it barely floats in a bath of the liquid. So when pressing the bath, the additional water enters the diver, thus increasing the average density of the diver, and thus it sinks. Okay. So why is it sinking? Pressing the bath, the additional water enters the diver, thus increasing the average density of the diver, and thus it will sink. Okay. So it is known as a Cartesian diver. So it is an experiment which demonstrates the principle of forward, that is a buoyancy. Okay. So next we will move to the Archimedes principle. So Archimedes principle is a consequence. Consequence means any impacts or outcomes of Pascal law. According to the legend, Archimedes devised the principle of the hydrostatic balance after he noticed his own apparent loss in weight while sitting in his bath. The story goes that he was so enthused with his discovery that he jumped out of his bath and he ran through the town shouting Eureka. Eureka is a Greek word and its meaning is I have found it. Okay, so he ran through the town and shouting Eureka. Eureka means I have found it. Archimedes principle states that a body immersed in a fluid experiences a vertical upward buoyant force is equal to the weight of the fluid is displaced. Okay, so when a body is partially or completely immersed in a fluid at rest, it experiences an upthrust or apparent loss of weight which is equal to the weight of the fluid displaced in it. Okay, so Archimedes principle is nothing but when a body is partially or completely immersed in a fluid at rest, it experiences an upthrust or apparent loss of weight which is equal to the weight of the fluid displaced in it. Okay, so now we understand clearly about Archimedes principle of buoyancy. Okay, so first here 5 kg of object immersed in a water shows it's acted upon by a buoyancy upward force 2 kg which is equal to the water displaced by the immersed object. The buoyancy force reduces the object of apparent weight by 2 kg, that is from 3 kg to 2 kg. Okay, so the upthrust, thus for a body either partially or completely immersed in a liquid, upthrust which is equal to the weight of the fluid displaced which is equal to the apparent loss of weight of the body. Okay, so upthrust is which is equal to the weight of the fluid displaced which is equal to the apparent loss of weight of the body. Apparent weight of an object which is equal to true weight of an object in air minus upthrust. That means weight of water displaced. Okay, so in this way we can find out the apparent weight. In the final concept for the syllabus is that is very important, laws of flotation. This is very important to mark. Okay, only 2 points, so you have learned easily. So what are the laws of flotation? There are two laws. So one is the weight of a floating body in a fluid is equal to the weight of the fluid displaced by the body. Okay, that we already learned in the Archimedes principle. The same principle we can use in that a law of flotation. Okay, the Archimedes principle. The weight of the floating body in a fluid is equal to the weight of the fluid displaced by the body. Okay, this is similar to the Archimedes principle. The second law is the center of gravity of the floating body and the center of buoyancy are in the same vertical line. Okay, here shown in the figure under the water, the buoyancy. Okay, so there is the floating body, this is the floating body, and the center of buoyancy or lie in the same vertical line. Okay, so these 2 points are the two laws or the flotation laws or laws of flotation. Okay, so can you clear? So I think this is up to this the lesson is over. Okay, so we can see the new lesson in the next video session. Okay, thank you for watching this video.